not recorded the first bit of this. So I'll start back over. I was recording this with on the WebEx, which doesn't always do well, so bear with me if you're watching that. I'll skip back here to the beginning. So in this discussion, I'm basically recapping Module 2. Module 2 is about basically data structures and data files, or data structures and data types, sorry. Data structure is pretty much what you would think. It's things like objects, classes, and data frames and so on, and dictionaries. The data frames in R are, you have your primitives in there as well, but also you have data frames as the more advanced one. Do feel free to read beyond the reading that's assigned for the particular assignments, and in fact you may find yourself going into the O'Reilly site and searching for a particular concept or theme and finding books that are potentially dedicated to just that. I'm certain you can find a book on pandas in there, so it may be worth taking a look at. We'll go through the basic concepts of Python, talk a little bit about map and lambda, and then data frames, dictionaries, and panda data frames. So basic concepts, Python is interpreted. There's not a compiler. There's not a compilation phase that occurs. Instead, it is executed as it sees the instructions. That means that you will encounter runtime errors unless you are amazingly good at writing code that never has a typo in it, which is improbable. So that means that you want to be good at diagnosing runtime errors as well. That's part of where things like Jupyter Notebooks come in handy, because they allow you to step through in a controlled fashion rather than running an entire script. So you can run a segment or a cell within the notebook rather than the whole thing. Keep in mind also in Python everything is an object. There are certain built-in types of objects that you'll utilize: text, numbers, sequences, mapping objects such as dictionaries, and types, set types such as what you would do with a Venn diagram, intersection, union, that sort of thing. Boolean for determining true or false values, and binary types such as bytes and byte arrays and memory views. We're not going to talk about that because it is an advanced topic, but it does exist. And there's also the type function, which allows you to see the type of a given expression. Here's the example notebook that I was just working through, and the basic idea here is that as I discussed previously, strings can be declared kind of 2 or 3 different ways, one of which is this internally, this inside of the double quotes or single quotes is a string. So what I'm basically saying here is take the string and turn it into a string. So it's probably not the smartest thing to do. But you can, more importantly, do something like take an integer and turn it into a string, which is what we're doing down here. So that is quite valuable. Also, numbers, a similar sort of thing. 1, 2, 3 is actually a number. So in the case without a period, it's an int. If you were to put a period on the end of that, it turns it into a float. So this is equivalent to the line above where I'm saying turn this string into a string. I'm saying turn this integer into an integer. We can also print out the types of the various variables that we declare. So this lets you kind of get a sense of things being floats. And this is potentially a float because it does have the decimal point in it. So you really don't need to say int to make it an int. You can just say 1, 2, 3. Sequences are essentially a series of things useful in things like iteration. If you want to do the equivalent of a for loop with a starting point index and an ending index, you're probably going to be doing it in a range because it allows it to iterate over the elements of the range. List is just what you would expect. It's a series of things that you could interpret several ways. You can add to a list using append. You can also insert at a certain location. You could potentially use it as a queue if you were so inclined. A tuple is a series of things that are related together that don't necessarily have a name but have an ordinal position. So in this case, we've got a tuple with 3 things in it, and the first item in that tuple is the 4, and then the second is the 5, and so on. You can't necessarily evaluate 1, 5, 4, or 4, 5, 6, but it is smart enough to know to turn it into a tuple because it has commas between it. A cool thing inside of Python is that you can return a tuple from a function. That means you can have multiple outputs of a function without having to declare some other type, which is how you might normally do it. In a different programming language, you might return a type or a structure that corresponds to the various values that you want to return. A mapping type is essentially an associative array or a dictionary. The idea is you have a name-value pair that you want to keep track of. Keep in mind inside of Python, you can mix your key types, so you can have a string or an integer be the index into a dictionary. Set types, as I mentioned, it's pretty much like a Venn diagram sort of exercise. You also have this concept of a frozen set, which is one that can't be changed, so it's essentially immutable. And your Boolean is what you would expect. It's a binary type. The way that Python and a lot of other languages actually handle the case is 0 is considered to be false, everything else is true. Sometimes it's 1 and 0, but it's the simplest form. If it's not equal to 0, then it's true. The binary types is typically associated with reading something from either a binary file or doing some sort of a binary-wise conversion. That means that you want to treat the elements that are inside of either the byte or the array of bytes as something that you don't know anything about. So it should not be interpreted as an integer or a number or a string. You can convert, as I did with the first line in the cell, basically an array of string characters into an array of byte characters. And so that's going to do, it's a binary representation of the same thing as it would be otherwise. So moving back over to kind of the presentation, skipping past the example notebook, talk a little bit about map and lambda functions. So basically you can think of lambda as an alternative to iteration. It's the equivalent of essentially saying run this method or do this operation across all of the items inside of the collection that I'm going to give you. So to again step into a real version of that, so you've got an array of integers and you define a function that says apply to a list, and you give it a list and it returns back some operation, in this case multiplying it by 2. And so we define that function, and you can have, in this case we're explicitly giving it a name, but we're also here using this lambda sort of thing that is doing the similar sort of concept. And so you can see that we're multiplying inside of here by 2, so that your array of these things become that. And so you'll probably want to get familiar with the use of lambda. It is quite powerful, but it may be different than what you've done in other programming languages. The reason that it is pretty compelling is that you don't care how necessarily those operations are being applied whenever we're talking about a lambda function. So in this case, we don't really care how the magic is occurring inside of this apply to a list, where we're basically saying do this function across everything inside of this list. And so in that case, that means that it could be potentially being done in a distributed and parallel fashion. And that's where things like koalas comes to play. Whenever you move into like a Spark environment. So something to keep an open eye on. So moving back over to kind of to stay on track, we have this concept of data frames and dictionaries. A data frame is very much of a row column grid-like sort of thing. You import it, most likely going to be using Panda's version of that, and it's very much seems to be inspired by R's data frame. Dictionaries are name value pairs. A lot of times they're called associative arrays. It's a primitive type, and it doesn't do a whole lot of things for you. So I'll show you the hard way first, and I'll actually take this further than what I showed here, because it is important to understand why Pandas is so cool. So this is code that's using the native basically file operations with a CSV reader. And basically what you end up doing is having to do a lot of the work yourself. So the end result is that once you exit the scope, if you don't do something interesting, this object ceases to exist. So stepping through it, at the point that I'm out here, the object still exists, but this file has been closed because we exited this with clause. And that means that you're not able to iterate across it because it hasn't been persisted anywhere. And that's one of the key things that you get with something like Pandas, is that whenever I do pandas.read CSV, I'm getting back a data frame that I can then use in a very advanced way with lots of nice functionality available to me. Obviously display, pretty useful, but you also have things that are natively available to you, such as describe, which gives you the typical statistics across most of the elements inside of your data frame. You can also take a look at the elements in there by at the first and at the tail, so head and tail, the first one record and the last record, just to take a quick look. You can also do things like box plots with the data frame, having loaded it in and being able to use it. So if you don't take anything else away from this conversation, data frames and pandas are cool, and you want to use them. You don't want to be doing it the hard way, because in order to do this, you end up having to do a fair amount of work yourself as far as persisting the values and so on. And with that, we've completed kind of the live portion. We'll talk a little bit here through pandas. If pandas isn't installed for some reason, you can install it with pip install pandas or conda install pandas, and you can see in my notebook over there that I did do a pip install, which I closed. I did do in my notebook a pip install pandas, primarily because I'd switched over to an environment that didn't have it installed. So my Conda environment didn't have it, so I quickly installed it. And you read very simply, just as what I showed earlier. It's as simple as you have a file name, and it's just read that file name, read CSV, and it returns back to you a data frame that you can then use to do all the manipulation. An example of that being done. So moving over to R, and we'll go over this pretty quickly because I'm trying to stay within roughly half an hour, and I lost a portion of that to user error. So data types in R, you've got your atomic and your basic data types. These are what you would expect: integer, character, numeric, complex, and logical. Very similar to the ones that you have available to you in Python, and you're going to find those data types exist in almost every programming language. You also have composite data types, and what that means is they're types made up of other types. They contain either complex types themselves or composite types themselves, or primitive types such as the integer, character, and numeric. Those composite types include vectors, matrices, and data frames. And as I mentioned, data frames very much associated with what you have with pandas. Here's kind of an example of, similar to what we showed on the other, of looking at the class of a particular type, so it tells you what it is. And you can also do the character afterwards to say that you want a long integer, or there's additional ones available as well, just as the I for complex. So that's kind of a standard thing. Also, you'll see across lots of different languages as well, a similar concept. The data types, composite data types, things like a vector, pretty much that's it's essentially like an array. You can think of it that way. It's not exactly, but that's close enough. And you also have a matrix, which is a n-dimensional sort of thing, so a number of rows, a number of columns. So think of it as very much like a grid. It might come in handy if you're doing matrix operation of some sort. And a data frame, you can think of it simplistically as essentially a matrix with columns, but it's so much more. They are frequently used, and probably one of the most common types of things you'll use as well. A nice thing inside of the RStudio is the ability to have it basically write the code for you to pull in data into a data frame, open up a file of interest, and it basically writes the code for you and inserts and executes it for you. So we're pulling in the Titanic data set here, and it basically wrote the Titanic arrow read.csv and then the file name. So pretty much took care of it for you. Probably if you're doing this for real, you want to save that off into a script and then do some additional error checking around that to make sure that the length is appropriate, determine if there are nulls and what columns and so on. And then basically using a data frame, you can see that it's very similar to what you do with pandas. It's just that the syntax is slightly different. Here we have head on a data frame versus head being a property or a method on the data frame in Python. The same thing with tail. The length or the number of rows, number of columns you get to similar by looking at the shape of it and so on. So you can see very much that there is a lot of overlap between the two, and rightly so, because it's a good way to do things. So with that, I'll go ahead and wrap this up. If you have questions about any of the material in this course, do let me know. I hope to help you be successful in wrapping this course up. Keep in mind, we are getting long into the course. I think we're somewhere around 3 weeks left, so it's time to get things turned in so that I can get them graded. Stay safe, and I'll speak with you next week.